Hello students. Here, in order to illustrate independent events, we have one problem, one question. Suppose an unbiased coin and an unbiased die are rolled. Unbiased coin is tossed and unbiased die are rolled. Then what happens? You have to let A be the event in which head appears on the coin, and suppose B appears in event B. Suppose an even number appears. Okay, let us say that an unbiased coin is tossed and an unbiased die is rolled. It is rolled. Unbiased die is rolled. Let A be the event in which head appears on the coin. Head appears on the coin, and B be the event in which an even number appears on the die. You have to check whether A and B are independent. How to check? We know that when an unbiased coin, a fair coin is tossed and an unbiased die is rolled, then what is the sample? How will you calculate sample space? A coin has only two outcomes, whereas a die has six outcomes. So for each outcome of a coin, we have six outcomes. So that means if it is showing head, then head 1, head 2, head 3, head 4, head 5, head 6. If tail is shown, then tail 1, tail 2, tail 3, tail with 4, tail with 5, tail with 6. Like this, we have got 12 outcomes. How we are writing? N of S is equal to 12. Now, they say that A is an event in which head appears on the coin. So that means H1, H2, H3, H4, H5, H6. And they say that in the event B, an even number appears on the die. Even number means we can have H2, we can have H4, we can have H6, we can have T2, we can have T4, we can have T6, because they are bothered about an even number, whether it is coupled with head or a tail. That is out of our botheration for set B. Now they say that you calculate A intersection B. What is A intersection B? Clearly H2, then H4, then H6. H2, H4 and H6. What is the probability of A? Obviously 6 out of 12. What is probability of B? Obviously 6 out of 12. What is probability of A intersection B? It is probability of 3 out of 12. So it is what? 1 upon 2. This is 1 upon 2. This is 1 upon 4. Can I say that P of A intersection B is equal to P of A dot P of B? Can I say like this? Yes, because 1 upon 2 into 1 upon 2 is 1 upon 4. Hence, A and B are independent events because they satisfy the condition that P of A intersection B is equal to P of A dot P of B. In similar way, we can have another question also. Say for example, if it die, um, we can have another question. Say for example, A and B are independent events. Okay, A and B are independent events such that P of A is zero point 0.3 and P of B is 0.4. You have to find P of A union B, second P of A intersection B, third P of A by B, fourth P of B by A. Clear? It is very clear, students, that P of A union B should be equal to P of A plus P of B minus P of A intersection B. But we should never forget that it is given A and B are independent events. So since A and B are independent events, P of A intersection B will become P of A dot P of B. So first P of A union B can be easily put it like this. P of A, that means 0.3, P of B मतलब 0.4, और P of A intersection B का मतलब होता है P of A into P of 4, P of A into P of B. इस तरीके से अगर आप करेंगे 0.7 minus 0.12, is it clear? So whatever is the answer, you can calculate and write it down. ठीक है? This will be how much? 58.58, right? 0.58. This is the probability of event A union B. Then if they are asking P of A intersection B, clearly it is, we have first found out this. Then P of A by B, third. P of A by B is nothing but P of A intersection B divided by P of B. What is P of A intersection B? Just now we saw it is 0.12. P of B is nothing but 0.4. So in whichever way you would like to say that 12 upon 100 into 10 upon 4. So whatever is the answer, you can just write it down and easily you can do it. Okay, it is how much it is going to become. If you take it out, 120 divided by 100, it is what? 4 3s are 12. Okay. 0.3. Like this you can calculate. P of A by B is 0.3. %30 probability. Then similarly they ask to find probability of anything they can ask like this. P of A by B, P of B by A, you can find it out easily. Okay, so in the next video we'll talk about Bayes theorem and its application, but a couple of questions more in the case of independent events.